I'll try to keep it very simple tonight. This is a talk on antibiotic resistance, but also a talk about how antibiotic resistance is handled by the media. And the first thing I would like to say is that maybe someone was attracted by the title, but I didn't read the book, I haven't seen the movie, 50 Shades of Grey, and I have to disappoint those who came because of the title. This is not an erotic talk. It's a talk about antibiotic resistance. And as I said before, it has a lot to do with how this topic is handled at the communication and political level, especially in Denmark. So I will try to guide you through some very basic questions that, in my opinion, are neglected by the media. And the first one is how many people die because of antibiotic resistance? We talk a lot about antibiotic resistance, it's a big problem, but can we quantify somehow how many people pass away because of antibiotic resistance? And the second one, who are these people? Because maybe you have never had the opportunity to meet someone dying because of antibiotic resistance. So I would like to tell you what kind of patients are more likely to pass away because of antibiotic resistance. And finally, there is a lot of talk about the use of antibiotics in pigs and in livestock in general. And I would like to provide you some data about the consumption of antibiotics in Denmark, in Danish pig production, and compare them to those from other countries, to see if it is really true that we use a lot of antibiotics in Danish pigs. But let's start with this introductory slide, which is showing how antibiotic resistance spread between different reservoirs. If you look at the blue arrows, these are the places where we use the antibiotics. We use antibiotics for treating ourselves in the community, in the hospitals, of course, and in livestock production to make production more effective and to avoid animal welfare problems. And then also in our households, once in a while, we may treat our pets with antibiotics. And whenever we use antibiotics, we exert a selective pressure on the bacterial population. We select for the resistant bacteria. And from all these environments, we spread the resistant bacteria, but also to some extent residues of antibiotics, to the rest of the environment. We do that through wastewater and animal waste. And of course, this may affect wildlife, but also some of the products that we get in our table, because we use animal manure as a fertilizer in agriculture. So there is a risk that resistant bacteria may be transferred via the consumption of contaminated food, including vegetables and, of course, meat. And the primary way of transmission is direct contact between animals and humans, is direct contact to the animals. So remember that also your household pet can be a reservoir of antibiotic-resistant bacteria. I chose the title, The 50 Shades of, because I wanted to give you an idea about the complexity of antibiotic resistance. The number 50 is just because I'm 49 years old, I'm approaching 50, so it has not a specific justification. Why it is complex? It is complex because there is a multitude of different resistant genes, resistant bacteria, and different antibiotics. So these are numbers that I have got from this ARDB antibiotic resistance database. And more than 13,000 resistant genes or presumptive resistant genes have been submitted to the database. It's a huge number. And they confer resistance to 257 antibiotics in over 3,000 different bacterial species. So this is a highly diverse phenomenon that is involving different bacteria and genes. But at the end of the day, the bacterial drug combinations that are causing problems in human medicine are not that many. And I have tried to list them in this table. forget about names, but I just want you to understand that some of them like infecting us in the hospitals. And the number one, carbapenem-resistant Klebsiella pneumonia, is a big threat. Fortunately, it is very rare in Denmark, but it is very common in the country where I come from, Italy. There are hospitals where the rate of isolation of this bacteria is over 50%. And when the situation is like this, you may well have very healthy people that enter the hospital and never go out. And then there are some bacteria that cause infections in the community, like normal respiratory infections or sexually transmitted infections, like Streptococcus pneumonia and Neisseria gonorrhea, respectively. But I have highlighted in bold these two bugs here, methicillin-resistant Staphylococcus aureus and E. coli producing extended spectrum beta-lactamase. I'm sorry for the terminology, but just remember MRSA and ESBL E. coli. I have highlighted these two because they are present both in hospitals and in the community. And on the top of that, they occur also in animals. So they are the bacteria that are most likely to be exchanged between animal and human reservoirs. And they are multi-drug resistance in a generic way, but they are resistant to a specific class of antibiotics that we call cephalosporins. And these are good antibiotics because we can take them orally, they are not toxic, and they are very powerful. So we care a lot about these antibiotics, the cephalosporins. And finally, there are, far away from here, in the developing countries, other bacteria like Shigella or Mycobacterium tuberculosis, which are also a problem. So let's start from the first question. How many people die because of antimicrobial resistance? Sorry. There are some data that have been released from, by the European Center for Disease Control, ECDC, showing for all these bugs that I have listed before, what is the amount of deaths that are registered every year and the number of infections. It is an estimate, it is a rough estimate, but these are the numbers we have. And the number says that in the EU plus Norway plus Iceland, every year die about 25,000 people. So you got some numbers. And 386,000 infections caused by this bacteria. Something I would like you to remember is that antibiotic resistance is not only a public health problem, it's also an economical problem. And why is that? Because there are costs whenever we get infected with this bacteria. We are absent from work, and we have to go back to the doctor because the antibiotic does not work. And the doctor at that time will have to take some additional diagnostic tests and prescribe a new antibiotics, which is more expensive than the previous one. And if we are hospitalized because of a serious infection, then the stay in the hospital will be longer. And you have to know that staying in a hospital for one night costs more than a 4-star hotel in Copenhagen. It is very expensive. And this is money that we pay as taxpayers. Of course, it's a national healthcare system, but in countries like Denmark and most European countries where this service is provided by the state, at the end of the day, it's money that we pay. So this has also been estimated, again, a very rough estimate, 1.5 billion euro, roughly 10 billion Danish crowns, which is, again, a lot of money. So let's try, there are no data about the number of deaths in Denmark, and I've tried to make some stupid calculation yesterday, taking into account what is the size of the population in Europe and the size of the population in Denmark. So it's a simple ratio. And I got this number from the calculation, so if the rate of mortality is the same in all European countries, then you would expect about 275 people dying because of antibiotic resistance in Denmark every year. And in my opinion, this is an overestimate. And why is that? Because in Denmark we have very low levels of resistance. So you remember the list of the superbugs. They are, most of them are quite rare, or at least they are less frequent in Denmark compared to other European countries. And I make an example. MRSA, you have heard about this word before, MRSA, isn't it? Is the bug that is associated with pigs. So in Denmark, we have a prevalence of about 1.5% in bloodstream infections. So I'm talking about serious infections. And on average, in all the other European countries, the prevalence is 22%. But as you can see on this map, where the green color, the light colors are indicating low prevalence, and the red color is indicating high prevalence, there are countries like Italy, Greece, Spain, France, and the United Kingdom, where at the time when the study was done, the prevalence was between 30 and 50%, up to 50%. And this is a very dynamic process. So for example, the UK has become orange or yellow, I don't remember, because they have invested a lot of money for antibiotic stewardship, for good use of antibiotics and control of infections in the hospital. But again, the bill, you have to understand always that the bill is paid by us, in a way or the other. So to combat resistance, but also to prevent. What about the human burden of MRSA infections in Denmark? Because there is a lot of talking about MRSA in Denmark. Here we have some reliable numbers we can base our opinion upon. So we know that every year, 5-6 people die of MRSA in Denmark. Is it a high number? Is it a low number? Well, taking into account the European data, if I extrapolated the number of deaths in Europe, about 50 people should die in Denmark because of MRSA. So we are about tenfold lower than in the rest of Europe. And taking into account the population size, of course. And in contrast, and this is something I would like to emphasize, in contrast, about 350 people in Denmark die every year because of normal Staph aureus, so Staph aureus that is not methicillin resistant. And one of the things I wonder as a research, if it is fair actually to focus all the attention on the 5 people that are dying because of antibiotic resistance and forget completely the 350 people that die because of bacteria that are not resistant. Well, let's dig more into that. What kind of people are they? Here again, we have some solid data. I mean, we know that people, the elderly people, old people, are predisposed to bacterial infection, and also the consequences are more severe in this category. And patients with underlying diseases, like patients undergoing transplantation or hemodialysis and cancer patients. They are the category at risks. And if you look at the data from 2013 in Denmark and see the mortality rate of Staphylococcus bacteremia blood infections, you see that the mortality is 0 up to 30 years old. Then you have a slight increase up to 17% of the infected patients up to 70 years old. And then you have a dramatic increase in the mortality rate. You see 30% between 70 and 80, and 41% when you are more than 80. So this is a piece of information that I think is missing completely when you read the articles on the newspaper. It's a big threat, yes, but let's look also at the people, at the type of people that are dying. And I'm not saying that these people are unimportant in the society. Of course, we should care about older people, like young people. But I think it's a piece of information that is quite useful for layout people to understand the problem. And if we look at the comorbidities, because this data, you have to know that this data reflect the number of people that die with Staphylococcus aureus or MRSA diagnosed, identified within 30 days before death. So you actually do not know if they died because of Staph aureus or if they died because of something else. Because if you look, maybe you cannot see very well, but I will guide you through. If you look at the number of comorbidities, here you have a list of different morbidities, and here you have the percentage. You can see that 1 out of 4 people with Staph aureus bacteremia has diabetes with chronic complication. And another 1/4, where is it? Yeah, here, 1 out of 4 patients have cancer. And 1 out of 5 patients have a kidney disease, chronic disease. So we are talking with people with a lot of problems that on the top of that get the infection with the multi-drug resistant bacteria within 30 days before they die. But did they die because of cancer, or did they die because of antibiotic resistance? We don't know. Did you know that? No. And then there is the pig MRSA, which we called ST398. This is just an acronym because we use a method for typing this bacteria, which is called multi-locus sequence typing. And ST stays for sequence type 398. This is a clone that is well adapted to pigs. And we know that many farmers in Denmark get infected. In reality, it's not an infection, it's a colonization, or maybe even a contamination, because we know that when the farmers stay away from work for a long time, most of them get free of this bacteria. So it's more likely a contamination in most cases. And what is the risk? We know that they can transmit the bug to the family members, so to their wives and children. And this is the situation as it is right now. And what we fear is that this bacteria may spread from the farm environments to the community. And if they start colonizing people that are not directly exposed to pigs, then the risk is that these people may bring actually the bacteria into the healthcare environment, into the hospitals. And what is the problem here is that in Denmark there is a very effective, I would say, control strategy, which consists in, for example, now in screening all farmers and veterinarians having direct contact to animals to check if they are MRSA positive whenever they go to a hospital for a simple check or for surgery. And this is very expensive. This costs a lot of money. So try to imagine what would happen if the prevalence from 1% would increase to 30%. Then a lot of people will be positive. And what happens when they are found to be positive? They are put in isolation rooms, and they receive a special treatment for decolonization. Okay? They get showered with chlorhexidine, some antibiotic in the nose, and some systemic antibiotic to get rid of this bacteria. So this is a cost, again, for the national healthcare system. I'm not able to quantify this figure, but it's quite expensive. But it is effective, because this is why we have so few MRSA infections in Denmark. Now, even, I say the prevalence is 1.5% among bloodstream infections, but we have seen over the last 10 years a slight increase. And this is showing the frequency of MRSA infections depending on their epidemiology. To make it more simple, depending if we acquire the MRSA in the hospital or here in the community or when we are traveling abroad. And what you have to look at is the orange line, this one, which is showing the ST398 clone. So it started in 2007, and there is a gradual increase in the number of infections caused by this pig MRSA. What is interesting to know is that now, in the last year, we have seen more cases in people that are not directly exposed to livestock. It's about 13% of the cases that are not exposed to livestock. So the scientific community is wondering why these people get infected with the pig MRSA. And one of the possible explanations is that there are other animal reservoirs. And one of them are horses. Do you like horses? Yeah. Yeah, why is that? These are data from a neighbor country, Germany, where they have tested a huge amount of samples from wound infections in horses. And not only horses, actually, also dogs and cats. But they found that the prevalence of Staph aureus and the prevalence of MRSA, you probably cannot read, but I cannot even read, MRSA, 9.4% of the samples had MRSA. And this is a huge number. This is a huge number considering that MRSA is not a normal inhabitant of the horse body. And especially when they type the bacteria using this method I mentioned before, they saw a lot. The green color is indicating the pig MRSA. You see it is present also among the dog isolates and among the cat isolates, but over 90% of the isolates from horses correspond to the pig MRSA. So after seeing this publication, I'm really interested now to know if horses in Denmark are a possible reservoirs. And I've been contacting several clinics and even the Horse Veterinary Association. And I must say that unfortunately they are very reluctant in collaborating because they are afraid of the consequences. So the hospitals, they are afraid about the consequences for the hospital staff if they find MRSA in the hospital environment. The riding schools, they are afraid of the consequence for their customers. And I understand that, especially because the atmosphere in Denmark about this MRSA, as I will explain in the next slides, is somehow tragic. I don't find the right word, but I will explain you later on what I mean. There are a lot of headings in the newspapers. You have probably seen, especially Politiken has specialized, there are a couple of journalists in Politiken. One of them is this lady here, who is writing articles on a frequency, once a week, sometimes twice a week, on antibiotic resistance with a lot of focus on the pig MRSA. And she wrote this article that every 5 packages of pork are full, which means contaminated with MRSA. And this is true. They made a study at the National Food Institute where they found that about 20% of the packages that we buy at the supermarket are contaminated with MRSA. And then this colleague of mine from Odense University made the following statement. It is in Danish, but I will translate it for those who are not Dane. The pig MRSA can transfer via meat, and it is a bigger problem than Salmonella and Campylobacter, which are typically foodborne pathogens, because it is a lot more resistant, and here resistant means that it is able to survive in the kitchen environment. And this statement has no scientific basis at all. No scientific basis at all. He waked up one morning and made this statement. Now, I know Hans, and he's a very nice guy, but I have to say that this is not correct. And it may well be that Sine misquoted Hans. But in that case, Hans, as a professor, has the responsibility to call the journalist the day after to make the correction on the newspaper. Do you agree? And I wanted to show you, well, we know very well that Staph aureus, at least it would be a new way of transmission of Staph aureus. It's possible that a few Staph aureus may be transmitted by the food chain, but it would be really a secondary route of transmission. And what I'm going to show you are some data that prove that so far, this Staph aureus has not been transmitted by meat. So this is the distribution of MRSA ST398 infections in Denmark, in the different regions in Denmark. So if you imagine that this bug is transmitted by meat, where would you see most cases? In Copenhagen, right? Here is where the majority of Danes live and eat meat. So proportionally, you should see a higher prevalence of infections here in Copenhagen than in Jutland. But the reality, Copenhagen, where is Copenhagen? Here, we had 2 cases in the last 7 years, and all the cases are from, or at least the most cases are from Jutland, with the 2, the north and the south of Jutland being the pigs. And why is that? Because most pig production holdings are concentrated in these two areas in Denmark. So this is a very strong argument, I think much more scientific than the one that he had no arguments. But by the way, I would like, Hans, are you here, by the way, because we can make it more interactive. Normally I don't like talking about colleagues when they are not present, but I got really fed up with all the statements that this guy has made in the press over the last years. And you can see here that some examples of these very frightening titles, like thousands are infected with the pig MRSA without knowing that. Or soon can we die of a simple bacterial infection. You see his name is here again. And the pig MRSA has costed another life. And I've told you what are the numbers. They are actually very low for all the MRSA. But I will show you also later on how many they are for this pig MRSA, here actually. So one of the things I would like you to understand that make me quite relaxed about the pig MRSA problem is that the mortality due to all the Staph aureus infections over the last 30 years have been extremely stable. About 20% of the people died. We have not seen an additive effect because of the introduction of this clone. So that means that the risk is more or less the same. And frankly speaking, I don't care if I die because of a normal Staph aureus or a Staph aureus that is coming from pigs. Okay? It's, as far as the risk is the same, I think there is not an impact on public health. And the data on mortality due to MRSA ST398 say that, Matteo, stay calm. This is my son that is... there are 5 deaths registered due to this bug in the last 7 years. 5 people died. And these people were, you remember all the comorbidities, were generally old people with a lot of comorbidities. So does this topic deserve all the attention that has got here in Denmark? As an expert, I would say, I don't think so. So what is going wrong here? And here, this is no more science. These are free thoughts from the speaker. I've tried to reconstruct what I think is a kind of communication blackout in Denmark. Why do we care so much about this pig MRSA? Well, first, Denmark is a country with a low prevalence with MRSA. So the healthcare authorities have an objective, which I fully agree, to keep this prevalence low. Okay, so we do whatever we can to keep the prevalence low. And one reason for doing that is that this search and destroy policy that I mentioned before, you identify a person that is colonized, the person undergoes a treatment for decolonization. It's quite expensive. So if the prevalence goes up, then we may give up with the policy because there is not money to control the problem. So this is probably the most important factor, I would say. And the second most important factor is that Denmark is one of the main pig producing countries. We are 5 million people, and every day there are about 25 millions. I have lost 25 millions only pigs. So, and it's an important industry in Denmark. So of course we export a lot of pork to other countries, and it's not a good commercial to export meat that is contaminated with this bacteria. And we have also a lot of farmers working in the farms, so we should care about these people. And then there is this aspect, which is a personal elaboration by me. I think something is going wrong with the communication. I call it the communication blackout. So let's start to reconstruct how this blackout starts. I think we, as researchers, have a responsibility, because whenever we are asked how important is the problem that we study, we say it's very important. You have to understand that it's very important. We tend to overemphasize the problem, and that is a natural attitude, because some of us want to get public recognitions, others want to get grants and stuff like this, career progressing and so on. Then I've been facing this problem many times with journalists. Any journalists in the audience? No? They are hiding. They are hiding. And the journalists, they always pick up the statement that is most scary to the people, because they want to make a nice heading, so that people look at the newspaper, oh, I should buy it, because this is about MRSA in pigs, which is a big threat. So they tend to even overemphasize more the problem. And then people get scared. They get scared and they start putting pressure on the politicians, because they say, hey, this is a big threat, so now you have to solve the problem. And the politicians, they don't know anything about antibiotic resistance, of course, but what they know is that they don't want to miss the votes of their people, so they need to react somehow. So what do? They contact us. They contact us, and this happened 5 years ago when the problem started. And they established this so-called MRSA action group. And so action means that we were supposed to develop a strategy for eradicating MRSA from pigs. So we sit down, we start talking to each other, and after a series of meetings, a long one, we found out that we didn't have any solution, because there were a lot of knowledge gaps. We didn't know how these bacteria enter the farm environment. We don't know how they spread, how many pigs are positive within an infected farm, how many farms are positive in Denmark. So we didn't have the knowledge to develop any strategy. So what are the negative consequences of this communication blackout? Well, first of all, there are serious social consequences for the people that are infected or are healthy carriers with this bacteria. This is another article on Politiken, and Kenneth became infected with the pig MRSA. And he says, people reacted like if I was infected with pest. So there have been a number of cases where people have received, let's say, a suboptimal treatment because they were infected with this pig MRSA. He had to give up his job. He worked for I don't know how many years as a farmer. He had his own farm. He quit the job. He couldn't stay in that situation. And more in general, there can be an impact on the Danish food industry. So this is an industry that is bringing to Denmark 25 billion Danish crowns every year. And more than 150,000 people are employed. So I think that whenever I make a statement on pig MRSA, I have to think also about these people, okay? Because they risk to miss to lose their job. And finally, the pressure the politicians receive all this pressure, so then they have to react. They don't know how to react, and sometimes they take irrational decisions. And here I have a good example. So after, you remember Sine, the journalist, she was writing 3 articles every week about the threat of pig MRSA. This started in August 2014 and lasted until November. At that point, the ministry decided 35 million to study pig MRSA in Denmark. Okay, and this money, this budget, was given to the Danish Veterinary Institute at DTU. Well, I got a bit disappointed by this news. Because I thought, first of all, why all this money to study the pig MRSA? I mean, there are some researchers here in the audience, isn't it? 30 million is a lot of money. I have to sweat a lot to get this money by grants. And so why all this money for MRSA? There are other problems that are as dangerous as MRSA. And why all the money to DTU vet? So yesterday I wanted to show some data, because without the data it's not a scientific talk. So there are 3 veterinary institutions in Denmark, okay? One is the National Food Institute at DTU. One is the University of Copenhagen, my group. And one is the Danish Veterinary Institute. So I searched in the database how many publications on pig and MRSA we all had. And these are the results. A good track record for the National Food Institute. There are a lot of competent people there. They got 0. Well, I don't want to comment on myself, but we got 0. All the money here, they have no publications. At least I was not able, maybe I missed some, but I was not able to detect any publication. So this is a bit irritating, because, yeah, it is. But it should be irritating also for you, because this is our money, okay? And I'm not saying that there are no competent microbiologists at the Danish Veterinary Institute, because this is not true. They are competent. But they have no track record of research in this specific topic. And then, this guy, I don't follow Danish politics, but I understand that this is the Ministry of Food and Agriculture, 5 days ago, made this statement. I established an expert group last year with the best experts in the country on this topic. This is at least, what could I say, an inaccurate statement? Can I say that? Okay. Good. I forgot to say something. That this budget is actually shared with Staten Serum Institute on the medical sector, and they are very competent, and they have a huge track record on MRSA. But what disturbed me is the money that was invested in the veterinary sector. So this is Carmen. She's here somewhere, there. And so now we don't have money to study MRSA, because I wonder if I write an application now on MRSA to the Danish Research Council, they may well think all this money has been given to the Danish Veterinary Institute, let them solve the problem. Why do you want to do research on MRSA? I'm afraid that this will be the situation, but let's see. She's doing very interesting research. She has done a extensive longitudinal study to count how many bacteria there are in the pig, in the nose of the pigs, how many MRSA and Staph aureus over time. So we have tagged the animals and we have sampled them different times. And what we found out is that there are some pigs, which here are in gray color, which we call the super carriers, which have a high numbers of Staph aureus in the nose and stable carriage over time. Whereas the others, they have low numbers and then sometimes they are positive, others are negative. So we believe that these pigs play a major role in maintaining MRSA within the infected farms. And what is interesting is that we have collaborated with the genetist at the University of Copenhagen, Professor Merete Fredholm, and she has actually sequenced the genome of these pigs. And we found that they have on the genome a locus, a small part of the genome that is associated with the supercarrier phenotype. And this is great, because now we can, for example, develop, if we will get any money, maybe we will not do it, but if we get some money, we can develop a diagnostic test to identify the supercarriers. And we can see what happens if you remove the supercarriers from the herd. And another interesting thing would be to use these for selecting pigs that are less susceptible to Staph aureus colonization, because we use breeding for making our pigs more fat and more productive. We could well use breeding for making them resistant to the MRSA. This would be quite an innovative approach to solve the problem. But I don't know, Carmen, if this will be the case. I'm sorry. Let's see. And I said, why all this money on MRSA? Is this the most important problem? I don't think so. So, for example, another problem that is emerging over the last years are you remember the ESBL producing E. coli? So if you go to the supermarket and you buy a package of poultry meat, you see here the Danish produced meat in 2013, you have 30% of probabilities to pick up a piece of meat that is contaminated with this bacteria. If you buy imported meat, this can go up to 50–60%. So we are exposed to this bacteria. But what is the difference? And now I try to keep it simple, because it is actually quite complicated. It has to do with the host adaptation. The difference is that Staph aureus is a bug that is used to live on pigs and is not well adapted to our body. And on the top of that, it cannot transfer resistance promptly to other Staph aureus. It's a big piece of DNA, it's difficult to transfer it in. Whereas this ESBL, they are located on plasmids that are very easily exchanged between E. coli. So to make a long story very short, if I ingest a single E. coli of animal origin, even if this strain is not able to colonize my intestinal tract, it can pass the plasmid to my E. coli. So there are no host barriers in this case. So I think this is a much more serious problem compared to the MRSA. But all the money was reserved for the MRSA, so let's see what will happen. Because the trend is that we are facing an epidemic worldwide with these ESBL-producing bacteria. And of course, there is a lot of geographical variation also in this. So if you go, what is the orange? I think it's Southeast Asia, yes. If you go to Asia nowadays, you will have 70% of the people carrying this bacteria in the intestinal tract. And if you stay here in Europe, there is an increasing trend, but we are still below 10%. But also the number of infections caused by these bacteria are dramatically increasing. So I thought it would have been interesting to invest also on this problem, for example. But the ministry does not agree. Last question. Do we really use so many antibiotics here in Denmark like we perceive by reading newspapers? And here, again, I wanted to show you some solid data from the European community, where the consumption of antimicrobials in humans and animals is compared between the different countries. And I will help you to identify Denmark. Denmark is here. And the blue color is indicating, these figures are adjusted to the total biomass. So they take into consideration how many people and how many pigs there are in all the different countries. But as you can see, even if we have a lot of pigs, the consumption of, you see the blue line here, the consumption of antimicrobials in Danish livestock is very low. It's among the lowest in Europe. And it's more than half, less than half than what we use in humans in Denmark. And you have countries like, well, I'm proud of being Italian. You have countries like Italy. We are always, if you see the rankings about Italy, we are either on the top or on the bottom, never in between. I don't know why. It's a crazy country. Anyway, you see Italy, well, if you compare, I don't know how many times what we use in Denmark. Is it 20 times? Yeah, about 20 times. And double than in human medicine. They use double antibiotics in animals than in humans. And if you go to Italy, I mean, I've been living in Italy for 28 years, and I often go there, discussion about antibiotic resistance. What? So I find this quite bizarre, that in a country like Denmark, we are a model in Europe, okay? I say we because I live in Denmark, but Denmark is a model in Europe about use of antibiotics and low levels of antibiotic resistance. But still there is this discussion that is completely crazy within the country. And maybe there is an explanation. Maybe the situation is so good because we have this discussion. Maybe we should see it in a constructive way, that this discussion is also, these data are a consequence of this discussion that has started many, many years ago in Denmark and never started in Italy. And it has not finished, because last week it was taken a decision that the Danish pig industry will have to reduce by 15% total antimicrobial consumption within the next 4 years, which I think is good. I mean, it doesn't harm. But the experts say this is not ambitious enough. And who is the expert? Hans. Yeah. So in his opinion, 50% is not a particularly ambitious objective. We should cut down antibiotic consumption by 90%. Based on what, Hans? So, I've been criticizing what Hans has said so far, but at the end, I will try to show you that maybe he's right. He's a bit naive, but he's right in his thinking. So let's see let's get to that point. What are the risks if we cut 90% antibiotic consumption? There are obvious consequences on animal welfare, okay? We produce pigs because we eat them. They live a very short life, a few months, and we slaughter them and we eat them. But still we want to give them a decent life. And if they become infected, and often they become infected because they are raised under very stressful conditions with the high pig density, and we would like to care also about their welfare. And then there are a lot of interesting, very interesting studies showing that if you underdose the antibiotics, you risk to select for resistance. So think about the veterinarians now. They got this yellow card rule. I don't know if you are aware of it, but if a veterinarian is prescribing antimicrobials above the average, he gets this yellow card, and he has to get down to the average because otherwise he gets the red card, which means money to be paid, fine to be paid. So the tendency now, the risk, I would say, is that veterinarians start underdosing antimicrobials, because that could actually impact also the selection of antibiotic resistance. And then now I move into an area where I'm not an expert, economics, but there is a potential impact also on farm sustainability, because they have to produce pigs and meat very cheap, because we want meat to be cheap. But what is the problem? The problem is that, I have 5 minutes late, I'm sorry, I'm 5 minutes late, sorry for that, but the problem is that this is a projection about the global human population. And as you can see, we are about here now, 7 billion people. And of course there is a big range. We don't know what in 2100, how many we will be. But the estimate is that we will be about 10 billion. So that means that the demand of protein will increase dramatically over the next years, especially in developing countries. And what is our consumption of meat and fish products? Well, there is a continuous increase. We eat more per person. We eat more and more, and especially we eat a lot of poultry meat now because it's white, looks clean, and it's good. We go to the gym, and it's good to eat a lot of poultry meat. Yes, let's do it, but let's realize also that this is going very slow. I don't know why. That I was not born at that time, but in 1950. We ate on average 24 kilograms of meat per year. And how much do we eat nowadays? Do you have an idea? Yeah, roughly double, more than double. Okay? So that means that development, this was very surprising to me. I didn't think that we were eating so much meat. So what about the price of meat? The price of meat, if you look at the red line, the blue line is the price of milk. Has been, yeah, there have been some fluctuations due to market factors. But if you look at the price in 1961, it is exactly the price that we have nowadays. The price of meat is very, very cheap. It costs more to buy a bottle of Coke than buying a full chicken almost. It's incredible, isn't it? So I think if we want to address the problem of antibiotic use in livestock, we need to rethink a little bit politically also and economically if we want to produce livestock in a different way. And now I link this to the thought by my friend Hans. So he believes that we can cut by 90%. He would like to see extensive farming like in the old days where the pigs are produced in small numbers and they live longer and they have a healthy life. But this will cost us because we will have to pay the meat at least double price. Are we willing to do that? Are we willing to eat less meat and pay it more expensive? Yes. Personally, yes. So at the end, I'm in favor of what Hans is thinking. He's not basing his statements on scientific evidence, but I like his philosophy. I don't know if it is economically sustainable, because you have to think also that the demand of protein is increasing in the developing countries, and they don't have actually the proteins to feed the animals. So here we have a huge problem that we will have to face in the years to come, which is the protein demand. probably bigger problem than antibiotic resistance. So some take-home messages here. So be proud of being Danish, at least with regard to antibiotic resistance. Denmark is among the countries where antibiotics are used most prudently, and the levels of antibiotic resistance are among the lowest worldwide, in both humans and livestock. And the way antibiotic resistance is presented by the Danish media is too frightening, in my opinion, and too much associated with pig production. So the few problems that we have are actually due to imported cases when we travel to other countries like Greece or Thailand or Italy. And then death due to MRSA, ST398, is extremely rare compared to death due to any Staph aureus. The proportion is 1 to 300 every year. And finally, because I know how many people are here. I don't know, there were 800, but let's say there are 500 people. So I would expect about 100 people here in the audience to have Staph aureus in the nose. And there is one unlucky person here that probably has an MRSA in the nose. So my last take-home message is to these people: you can live a happy and healthy, you can have a happy and healthy life with Staph aureus or MRSA in your nose. And saying that, I would like to thank you for your attention.